Okay, today we're going to look at section 8.1, gathering and organizing data. So when a polling organization wants to try to establish which candidate will win an upcoming election, the first steps are to write questions for the survey and to choose which people will be asked to respond. These can seem like simple steps, but they have far-reaching implications in the analysis the pollsters will later carry out. This process, which samples or this process by which samples or units are chosen can strongly affect the data that are collected. Units are anything that can be measured or surveyed, such as people, animals, objective experiments, and data observations made on units. So we're going to look at several different types of sampling methods. First method we look at is a simple random sample. It's chosen in a way that every unit in the population has an equal chance of being selected. And the chances of a unit being selected do not depend on a unit's already chosen. In other words, everybody has the same possibility of being chosen. And say my brother was chosen, that should not reduce the chance of me also being chosen. Next, we have a systematic random sample. This is selected from ordering a list of the population. For example, names sorted alphabetically or students listed by student ID. Now there could be an issue with this, a systematic random sample. If I put it in alphabetical order and I was to be chosen, chances are that person is not going to choose somebody else close to me on this list, such as my brother. A stratified sample is chosen so that particular groups in the population are certain to be represented. In a stratified sample, you would first divide the population into groups or strata, then take a random sample within each stratum. So we'd have different groups and we'd randomly pick some people from each group. A cluster sample is a sample where clusters of units are chosen at random instead of choosing individual units. It might be people that lived on block, that could be a cluster, or anything of that nature. So look at our example here. For each of the following situations, identify whether the sample is a simple random sample, a systematic random sample, a stratified random sample, or a cluster random sample, or none of these. So we have the chairperson of the University Chess Club is trying to decide on a time for the club's regular meeting. So she emails all of the members of the club to find their preferences. This would be, I would go with cluster. All she's doing is the group of people in the club. Of course, makes sense. The registrar at a small college wants to use a survey to determine if their office could do a better job serving students. They choose 3 students at random from each major to take a survey. This could be, it would be stratified, the strata being the different majors. The civic club is organizing a raffle as a fundraiser. As each of the tickets is put in a large drum, then it's 30 minutes and a blind. Well, this would be a simple random sample. Simple random sample. Everybody has a same chance of winning. Once we've collected our data, we must turn to analyzing it. Before we can analyze it, we probably want to reorganize it in a format that makes the analysis easier. We have 2 broad types of data, categorical and quantitative. Categorical data classifies the unit into a group or category. Quantitative data is a numerical measure of the property of a unit. So categorical data, the best way to organize categorical data is use categorical categorical frequency distribution, which is a table with two columns. The first contains all the categories present in the data, each listed once. The second contains the frequencies of each, which are just a count of how often each category appears in the data. So students in a statistics class were asked to provide their majors, and it's done in the below. So you would have our categories. We're going to create a category frequency distribution. So we start off, we have undecided, undecided, political science, biology, sociology, and that seems to be it. And this would be our frequencies. How often do each of these occur? So undecided, I have 1, 2, 3, 4. So that is the frequency. Political science, I have 1, 2, 3. Oh, I missed one, didn't I? Education. Okay, biology. 1, 2, 3, 4, 5, 6. Sociology, 1, 2, and education, 1. And there we have made our categorical frequency chart. Now we come to quantitative data. We have a couple of options available for organizing quantitative data. If there are just a few possible responses, we can create a frequency distribution just like the one we made for categorical data. So, question on a community survey asks each respondent to give the number of people who shared their residence, and the data from the responses is below. So there are what, 5 different answers? 1, 2, 3, 4, 5. So we don't have that many possible answers. So we can use a frequency table in this case. So we'll go ahead and, well, we won't call it a category. We'll call it number of people. We have 1, 2, 3, 4, 5. And then we're going to have how often it occurred, frequency. So let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Had 12 with one family member. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 13 with two family members. 1, 2, 3, 4, 5, 6, 7, 8 with three family members. 1, 2, 3, 4, 5, 6 with 4, and it looks like there's 1 with 5 right here. So that's one way to do a distribution for quantitative data. However, if there are many possible responses, a frequency distribution table like we've been doing isn't really useful. If there's 100 possible answers or possible responses, I'm not going to have 100 different listings. That would get kind of bulky and isn't really useful. So what we do is we do something called a bend frequency distribution. A bin frequency distribution groups the data into ranges of values called bins, then records the number of response in each bin. So how do we do this? Well, first we identify a max and minimum value in the bins. We want to get a rough idea of bin width. We want to consider the context of the values, create the table, complete the table with the frequency, and then check your work. So here we are with ages of customers. So our first step is what's our minimum and what's our maximum? Now here's a 56. Do I get any larger than that? Oh, there's a 70. So my max is 70. What's my minimum? There's 26. There's another 26. So my range is from 26 to 70. So how do I want to arrange? Well, let's see. What's the difference? 44? So we could have, what if we go and make our range from 25 to 70 and have 5 bins, 9 each. So my first bin will start at 25. My second bin is going to start at 34. So this bin ends at 33. And 40, 43, nope, 42. This is 43, 51. This is 52 to 60. And we didn't quite make it, did we? So let's go 5 bins with 10 each. 25 to 34. It does take some trial and error. 45 to 54. I know what you're thinking. I can hear it. But professor, those are only 9 apart. But the numbers in this bin here are 25, 26, 27, 28, 29, 30, 31, 32, 33, 34. Bin width is between low end or between high and not between the two. So we have our bins and now we want our frequencies. So let's see. 25 to 34. Let's see. There's 32. 1, 2, 3, 4, 5, 6, 7, 8. Okay, 35 to 44. 1, 2, 3, 4, 5, 6. 45 to 54. 1, 2, that's it. 55 to 64. 1, 2. Yep, we missed this one here. 2. And then we have the 170. And then we need to go back and count for this one. We have 14, 17, 19, 20. And 1, 2, 3, 4, 5, 6, 7, 8, 9. 10 times 2 is 20. So there we are. There is our band frequency distribution. And that ends section 8.1.